Dijkstra's algorithm. It is used for finding the single source shortest path. The single source shortest path problem is, for a given vertex called the source vertex in a weighted connected graph, we have to find the shortest path to all its other vertices. For example, if we have 5 vertices in a graph A, B, C, D and E, and if we select B as the source vertex, then we have to select the shortest path from B to A, B to C, B to D and B to E. That is, from source vertex to all other vertices we have to find the shortest path. Most widely used applications are transportation planning and packet routing in the communication network, including the internet. Then less obvious applications include finding shortest paths in social networks, speech recognition, document formatting, robotics, compilers and airline crew scheduling. In the world of entertainment, one can mention path finding in video games and finding best solution to puzzles using the state space graphs. This is the idea of Dijkstra's algorithm, that is how it works. Initially it will begin from the source vertex. Here we have a source vertex, for example V0, and here it will find the shortest path to all other vertices. So here this is shortest path for one vertex, shortest path for another vertex. To find the shortest path for next vertex, it will keep on adding, it will keep on creating the spanning tree, almost like it works like a spanning tree. And here, while finding, for example, if V star is the one which has found and it is present in the spanning tree, from V0 to next vertex selected, next nearest vertex selected will be U star. The U star, that is depending on the distance from V star to U star, we are going to select that. That is idea of Dijkstra's algorithm. The subtree of the shortest paths already found is shown in bold. The next nearest to the source vertex V0, U star, is selected by comparing the lengths of the subtree's path increased by the distances to vertices adjacent to the subtree's vertices. Consider this example. We have 5 vertices here, and here we have, each edge will be having its own cost, we can notice. So here let us consider A as the source vertex. So if A is the source vertex, we have to find the shortest path from A to B, A to C, A to D, A to E. So here we have to add each vertex every time. It works like the Prim's algorithm, almost similar to Prim's algorithm, but here we are going to find the shortest path. So here first we have to select one source vertex. Any source vertex can be selected. Here first vertex, that is A itself, is selected as the source vertex. Then we have A to B, which is 3. A to C we don't have any direct edge. A to D we have 7. A to E we don't have direct edge, so it is infinity. If we don't have direct edge, we have to write it as infinity. If we have direct edge, just mention its length. So A to B is 3, then A to D is 7, that is specified here. Then among the remaining vertices, select the one which is having smallest length. So here 3 is the smallest cost, so A to B 3. So next edge selected will be A to B, and that will be added to the spanning tree. And then here, since we have to find the shortest path, now from B, when we are going to select A to B and B to C, we have to add. So B to C, direct edge is there, so it is 4. So B to C is 4. A to B, it is 3. So 3 plus 4, which is equal to 7. That is the distance from A to C. So 3 plus 4, which is equal to 7, is the distance from A to C, that we have to add here, because it is not just a spanning tree construction here. It is, we are going to find out the distances from source vertex to all other vertices, so it is necessary. Then B to D, A to D, it was 7. A to D direct path was 7, but through D or via D it is 3 plus 2, which is equal to 5, and that is lesser than 7. So add the new path. Here we have to find the shortest path. So add the new path. So D to B is 2, A to B is 3, so 3 plus 2, which is equal to 5, and B to E we don't have any direct edge, so we cannot add it. It was infinity, write it as it is. And then next smallest distance path will be added to the tree. So B to D, which is equal to 5, that means B to D is added, which is equal to 2. So 3 plus 2, which is equal to 5, that is selected here. Since we need that distance, that is specified here, that is 5. Then B to C, it is 7, that is previous value itself we have written. So D is selected. So if we consider D to C, so it is A to D is 5, 5 plus 5, 10, but previous value was 7, so write it as it is. Then D to E, via D we have the distance as 4, so 5, A to D is 5, 5 plus 4, which is equal to 9, that will be added here. Initially it was infinity, now it has been changed via D. So D to E is 5, so D to E is 4, A to D is 5, 5 plus 4, which is equal to 9. So next path selected will be B to C, that will be added to the tree. Then the path is 7, that is from A to C is 7. Now the remaining vertex, it is E, so D to E is equal to 9, that will be selected here. So here at the end, when we write the length from source vertex to all other vertices, so A to B it was 3, A to D via B, that is A to B, B to D, it is 5, then A to C via B, A to B, B to C, it is 7, then A to E via B and D, that is A to B, B to D, D to E, it is equal to 9. This is the Dijkstra's algorithm for finding single source shortest path.